All right. I gave you guys all a investigation that you should have completed prior to this lesson. A lot of what you're going to hear and see in this lesson is based on what you saw in that investigation, and this lesson will make a whole lot more sense if you have done that. So if you didn't, stop this video, please go back and do that first. So what you looked at in that investigation was vertical and horizontal shifts of different functions. So this whole unit is based on transformations of functions, and what we're focused on today is shifting vertically and horizontally, okay? In terms of a vertical shift, if we have a function y equals g of x, if that is a function, and some constant k, then y equals g of x plus k is a vertical shift. A couple of stipulations here. If k is positive, then we shift up k units. If k is negative, then we shift down k units. Okay, so again, this is information that you should have seen in that investigation. Shifting horizontally, on the other hand, if y equals g of x is a function, and again, k is a constant, then y equals g of x plus k is going to be a horizontal shift. So notice the difference in the placement of where your k is in these two different types of shifts, and we'll talk about that more in just a minute. Stipulation again here, this is a little bit different. Here, if k is positive, then we shift left k units. If k is negative, we shift to the right k units. So the big difference here, hopefully you are seeing, is taking that constant k, we can add that constant k to the very outside of our function. This is what we call an outside change. Or we can take that constant k, add it to the inside of the function, which we call an inside change. So now what we're going to do is generalize what we call inside changes and outside changes. So in general, any change to the input of a function results in a horizontal change in the graph. Any change to the input of the function results in a horizontal change in the graph. So again, that example, y equals g of x plus k. Changing the input is going to result in a horizontal change. On the other hand, any change to the output of a function results in a vertical change. So that first example we saw, y equals g of x and then plus k. So let's really look at the difference in changing the input versus the output. If you look at the next page. Okay, so it says to complete the following tables using that function f of p that is given to us here. And then for g of p, that's going to be an inside change, adding 2 to the input. And then h of p is going to be interesting. This is different than my notes. Okay, we need to change this real quick. H of p should not say that. H of p should be f of p minus 2. This should be an outside change. I'm not sure why that's different. Okay, so sorry about that. So h of p is going to be a minus 2 on the outside, a change to the output. So here's what we're going to first just start off by doing. Let's fill in this chart with just values for f of p. So just from that original function f of p, finding those f of p values. So the quickest way that I do this is I just put this function f into my calculator, into my y1, and then I go to my table. Okay, so type in your graphing calculator that p squared plus 2p minus 3. Don't really need to graph it at this point. I just want the table of values to get those function values. So do that and make sure that you're getting the same f of p values as I am, which should be 0, -3, -4, -3, 0, 5, and -12. So again, you can certainly take each one of these p-values, substitute it in the function, and get your function values, but I like to kind of use that technology with our graphing calculators. Just plug this function in your y1, look at your table of values, and you can get all of those right away real quick. Let's go ahead and take a minute, plot these values on the graph to get that function f. So I'm going to stop the recording real quick and just plot those, so when we come back, I'll already have the graph on there. Okay, so you should have plotted those points. You can see that we have a parabola. We should have known that just from the function itself being a quadratic. Okay, so let's get to what we're really kind of focused on here. So let's look at finding these values for g of p. So what we're doing is we are adding 2 to the input. Okay, we're adding 2 to the input. So for example, if I take this first value of p, which is -3, think about taking that value of -3, putting it in for p. So I have g of -3 equals f of -3 plus 2. So I'm taking that plus 2, I'm changing the inside or changing the input. So this is really not f of negative 3, g of negative 3 is really the same as f of negative 1, which f of negative 1 we know from our last table is negative 4. Okay? So what I want you to start thinking about is, okay, g of negative 2, how does that relate to function f? So if I'm looking at my next p-value, so when p is negative 2, think about plugging that in up here. I'm adding 2 to this input. So this is really like f of 0, which is negative 3. If I continue that, so negative 1, that's really like f of what? Well, take negative 1, add 2. So this is really like f of positive 1, which is 0. Okay? Now, a couple of things that I want you to notice. I'm adding 2 to the inside. If you look at the first two charts, if you look at these values, they're really moving over 2 units. And that's really going to correspond to what happens to the graph as well. So if you think about that, then I can take the 5 and negative 12, go ahead and enter those in. And I don't know why I have that negative. That should be positive. So this is 5 and 12. And then these next two values are 21 and 32, which are totally off our graph. But we can then go ahead and plot those values on our table. So negative 3, negative 4, negative 2, negative 3, and so on. What we end up with is a parabola that looks like this. So not only did those function values move to the left 2 in the chart, but look what happened to your graph. Okay, so adding 2 to the input shifts the graph, like we said on the first page, shifts the graph left 2 units. Okay? All right, let's finish this up by doing function h. So this time, function h, I'm taking f of p values and I'm subtracting 2. So I'm changing the output here. So really all we have to do is go back to those original f of p values, take all of those, and subtract 2 from it. So here, h of negative 3 is taking that f of p value and subtracting 2, so negative 2. H of negative 2 is taking the corresponding f of p value, subtracting 2, so negative 5, and so on. So I'm taking all of these output values, subtracting 2. Okay, and then we can plot those. And so on. So what we get is yet another parabola, but we're concerned about how it's shifted based on, or how it's shifted from our original function f of p. And we can see that from f of p to h of p, we have shifted down 2 units. And that, again, is coming from that outside change of -2.